All right, so today we're going to look at the 0 to 4 notes, rational functions, but we're going to look at how to find vertical and horizontal and slant asymptotes. So last class you looked at the intercepts. This class we're going to look at the asymptotes. So what line is the graph approaching? So first, to find the vertical asymptotes, we're going to set the denominator equal to 0, because that's, remember on day 1, how we found our domain restrictions. So in this case, what value for x will make the denominator 0? The answer is -3. If I plug in -3, I'm going to get 0 in the denominator. So the way I write an asymptote is x equals -3. That's a vertical line at -3. The way I write my domain restriction is I say x cannot equal -3. So the way you write a vertical asymptote is with an equal sign. The way you write domain is with a does not equal sign. So the next part is not factored in the denominator. So your first step would be to factor the denominator. And this happens to factor x minus 1, right? Because -1 times -1 is 1. Outer plus inner adds up to -2x. So it looks like the only undefined value will be when x is +1. 1 minus 1 will give me 0. So x cannot equal 1 is how you would state the domain. So vertical asymptotes, we're going to set the denominator equal to 0. Those are actually the easier asymptote to solve for, because the horizontal and slant asymptote actually has 3 different scenarios. So a horizontal asymptote, right, would go side to side on your graph. A slant asymptote goes vertically on your graph, and then your graph approaches it. So here are the 3 scenarios. Basically, the numerator is going to compete against the denominator for who is the bigger power. So you just studied polynomial functions. We're looking for the highest power, meaning the degree of the function. So first step is, what if the larger power is in the denominator? See how the denominator wins here, right? So the denominator has a bigger degree, right? Denominator has higher degree. Then y equals 0 just is your asymptote. If you have a small number like 1 in the numerator, and you have a huge number that you plug in for x, like 1,000,000, 1 divided by 1,000,000 would be 0.0000001. And a small number divided by a huge number approaches 0. So y equals 0 is the horizontal asymptote. So the next scenario, maybe the numerator and the denominator are equal in degree, right? So linear function. They both have a degree of 1. So then what you do is you peel off the coefficients. So if you plug in 1,000,000,000, this little +5 and this little -2 is not going to make much difference. But you'll have 2 billion in the numerator and 3 billion in the denominator. So that's going to approach the number 2/3, right? 2 billion divided by 3 billion is about 2/3. So y equals 2/3 is your horizontal asymptote. So horizontal asymptote at 0, horizontal asymptote at whatever the coefficients are. So scenario 3, now the numerator wins the battle. So numerator is a bigger power, like a quadratic. This time, there's no horizontal asymptote, there is only a slant asymptote. And I said only if the difference of powers is 1. So x squared and x, they differ by a power of 1, and you have to do division, right? It's a slant asymptote, sideways asymptote, but you have to do division. That's why last class we learned polynomial division. So let's practice our division a couple times. I'm going to practice synthetic division on G. So plug -4 into 2, 3, -1. 2, 3, -1. If you prefer the box method, just ignore me and do the box method. Bring down the 2. -4 times 2 is -8. Add together. negative 5, negative 4 times negative 5, positive 20, add together, 19. So my slant asymptote is y equals 2x minus 5. I do not care about the remainder. The remainder is actually what keeps me from reaching my asymptote. So if this divided perfectly, they have a common factor, so there's a different scenario. You want there to be a ratio or a remainder if there's a slant asymptote. Let's practice this next one using the box method. If you're going to do synthetic division on this one, I just wanted to set up the numbers for you. See how you have 1x cubed, but you have 0x squared? You need to write 1, 0, negative 2, 9. So you have to put a placeholder in if you're missing one of your terms. But I'm going to do the box method to practice my other method here. So the box method, I'm plugging x plus 2 into x cubed minus 2x plus 9. X times x squared is x cubed. X squared times 2 is 2x squared. How many x squareds are there? Remember, there's 0. So to balance this out, I need negative 2x squared so that adds up to 0. So negative 2x goes up top. Negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x. How many x's did I want? I wanted negative 2x. So positive 2x goes inside my box to add up to negative 2x. So the last part of my quotient up here is 2. 2 times x is 2x. 2 times 2 is 4. Must have a remainder of 5, right? Because I'm trying to get to 9. 4 plus 5 is 9. So now here's my function. Y equals x squared minus 2x plus 2. Do you see anything wrong with that? I did my division correctly. A cubic divided by a linear function is a quadratic function. What does it say up here? There's actually a slant asymptote only if the difference in the powers is 1. Wasn't the difference in powers here 2, x cubed, and a linear function? So this is the correct division, but this is not a slant asymptote. So a slant asymptote is a line. We just got a quadratic. So it's only going to be a slant asymptote if they differ in powers by 1. All right, so this last one I didn't leave enough room for. And here's the case when you can't use synthetic division because your denominator is a quadratic. So we're all going to have to practice our box method on this last one. Hope I don't run out of room here. So I've got 3 terms, x squared plus 2x plus 1. So I'm trying to get x cubed here. So x goes up top. X times 2x is 2x squared. 2x squared, x times 1 is x. I'm trying to get how much? I'm trying to get negative 2x squared. So I need negative 4x squared to get there. So negative 4 goes up here. That's actually the end of my slant asymptote. All this other stuff's going to be remainder. So I'm just going to stop there. Y equals x minus 4, and it has kind of a yucky remainder. I could keep going. Negative 8x, negative 4. So this would be what? 9x minus 5. So my remainder is 9x minus 5. I don't really care about the remainder. All right, so you've got your 3 different methods for your horizontal asymptotes. So our next page that we're going to look at together is finding vertical and horizontal asymptotes for each of these. And there are 8 practice problems we're going to do together. And then you are going to finish up by doing just these last 3 problems on 0 to 6, which you got to flip ahead a couple pages. So this is the only page you're submitting for today, 0 to 6. So once we're done with these 8 examples, hopefully you'll be a pro at finding vertical and horizontal asymptotes. And then tomorrow we're going to put all these skills together to graph our functions. All right, so remember, vertical asymptote. Let's do those first and knock those out of the way. I'm going to set my denominator equal to 0. So when will x minus 9 be 0? When x is 9, right? Add 9 to the other side. When will x squared minus 9 be 0? So this is solving a polynomial function, right? Factor it, difference of squares, x plus 3, x minus 3 equals 0. X could be negative 3 or positive 3. So those are the actual equations of my asymptotes because those are my x-intercepts, right? Where the denominator will be 0. Where will this one be 0? So when will x minus 8 be 0? When x equals 8. All right, when will this polynomial, so x cubed minus 2x squared, when will that be 0? So I need to use some factoring here. Looks like I could pull out a greatest common factor of x squared. What do I have left? X minus 2. So what are my two possible vertical asymptotes? 0, right? Because 0 times anything is 0, and 2, because 2 minus 2 will give me 0. So x equals 0 or 2 would be my vertical asymptotes. I'm going to stay on the roll here of vertical asymptotes and go to the back page. All right, vertical asymptotes. Will x squared plus 4 ever equal 0? So if I subtracted 4 to the other side, don't I get negative 4? Can you take the square root of a negative number? No. And x squared plus 4 is really a quadratic that's been shifted up 4 units. So this has no vertical asymptotes. It's okay to have no vertical asymptotes sometimes. All right, where is this denominator, 2x squared, going to equal 0? Divide by 2 on both sides, x would have to be 0. Where would this denominator equal 0? So when will x plus 1 equal 0? Subtract 1 to the other side, x has to be negative 1. And this last problem, when will x be 0? Well, when x is 0. So you may want to pause the video now that you're keen on vertical asymptotes. You may want to just go through and do 26, the 3 vertical asymptotes, and then come back in a minute. But I'm going to keep going and do the horizontal and slant asymptotes. So I think what I'm going to do, just to keep the different rules straight in my head, let's just skim through and look for this first scenario. The numerator is exactly 1 higher degree than the denominator. So then we're going to have to do division. So not higher here, they're both x and x. Not higher here, x squared's on the bottom. In h of x, the numerator has a higher power than the denominator. So I'm going to do my slant asymptote division. So I'm going to take x minus 8 and divide it into x squared plus 6x plus 5, just like I've been doing for practice. So x times x is x squared, x times negative 8, negative 8x. I'm trying to get 6x, right? So if I have negative 8x, I have to add 14x so that I get positive 6. So it looks like x plus 14 is going to be my asymptote. I really don't care about the rest because it's all remainder. So y equals x plus 14 is the equation of my asymptote for that one. Let's see, is the numerator bigger in j? No, it is not. Is the numerator bigger in m? Nope, they're both x squared. X squared's in the denominator. Q of x. It looks like the numerator is bigger, powered, x squared in Q of x. I'm going to do this one by synthetic division. So I'm going to plug in -1, remember it's the opposite, into 3, -2, and 5. 3, -2, and 5. Bring down the 3, -1 times 3 is -3. Add them together, -5. -1 times -5 is 5. 5 and 5 is 10. So my asymptote is 3x minus 5, right? Because that's my remainder of 10. And in this one, the denominator is bigger. All right, so we did our first rule. We found all of the occasions when the numerator was higher. So now let's look for all the occasions now when the denominator wins. And my answer is just going to be y equals 0 whenever I see that. So x and x, they're tied. Denominator's bigger here, x squared. So I have a horizontal asymptote at y equals 0. Denominator's bigger here. So it blows up and gets big. So it's going to approach a value of y equals 0. Let's see, x squared and x squared are the same. X squared is in the denominator this time, so y equals 0. Horizontal asymptote at 0. Denominator's bigger in t of x, so y equals 0. So my last rule for asymptotes, if the powers are equal, the horizontal asymptote is the ratio of the coefficients of the leading terms. So if I have x over x, I'm going to strip this 1x and this 1x. 1 divided by 1 is 1. Did all the rest on that page. So my last example, I have 2x squared divided by 1x squared. 2 divided by 1 is 2. So my horizontal asymptote is at y equals 2. So today it's kind of just memorizing, practicing how to find asymptotes. So you're going to wrap up today by answering these 3 questions on 026, and you only need to submit 026 for your work today.